This is the recording for the unit review additional practice. So this is just more practice doing what we need to do to practice for our unit test. This is after investigation 5, so you should know how to do anything with percents. So I did allow you to use a calculator because there's some complicated math in here, but on the unit test you will not be allowed to use a calculator. The first question is just a straight graph question, so we need to look at the graph and see what it's telling us. The Student Council at the middle school conducted a survey to see whether students would prefer blue, red, or green as a new color. The results of the survey are shown. So the first question is, what is the total number of students who were surveyed? Well, we need to look at our graph. It looks like blue was 40, red was 30, and green was 60. So if we add the 40 plus the 30 plus the 60, we get 130. So that's the first part. You need to know what your whole is. So our whole is 130 students. What percent of the students preferred blue? Blue was up here, it was 40, so 40 out of the 130 students gives us 307 thousandths, so that comes out to be about 31%. What percent preferred red? Red was 30, so 30 out of 130, again you could have used your calculator, ends up being about 23%. And then what preferred green? There's a couple ways you could do it. You can go back up and look at the graph and see that it was 60. 60 out of 130 is 46%, which makes sense because 60 out of 120 would be about half, so it's less than half. So 46%. Or you could have used what we had before. B was 31%. C was 23%, they need to add up to 100%. So if I take 100% and I subtract the 31 that I already have and the 23 that I already have, that leaves us 46%. So that's a way to double check that your percents adds up. So 31% was blue, 23% is red, and 46% is green, which I think we'll go right ahead in here and do our word for the day. Our code word is, because of these red, greens, and blues, is making me think of M&Ms. So the code word is M&Ms. Okay, going on. Now we're trying to figure out if there's 130 students who answered the survey, but there were 970 students total, how many percentage did the survey? So again, it's fractions, it's part to whole. So 130 students did the survey out of 970 total. 130 divided by 970 comes out to be about 13%. So not a great return on how many people did the survey, but anyhow. Moving on, and then now we're just doing percent questions. What percent of 75 is 40? So this is what we talked about in class today, how you can kind of have these percent questions in 3 different ways. I'm going to peek up at my board to remember what we said. We said like you could have a number is what percent of another number, or we could have what is a percentage of a number, or what is number is a percent of a number. So that's really clear, but like 76 is 80% of what? Or what is 85% of 120, or 85 is what percent of 200. There's all these different ways the percents can be worded. The key is to put it in a way that you understand. So in this way, what percent of 75 is 40? This is a part to whole again. 40 is your part and 75 is your whole. So if you're looking for a percent and you have 2 parts, you always do the part to whole. 40 over 75, you can use your calculator, gives you 53%. What percent of 45 is 135? I kind of wrote it the other way. So this is tricky because I just said smaller numbers, but not always. So what percent of 75 is 40? This is the same thing. What percent of 45 is 135? But you're actually going to get an answer greater than 1 in this. So 135 is what percent of 45? You take 135 and divide by 45, and it actually comes out to 3 even. So you can have a percent that's, if this is 300%, so you can have a percent that's more than 100 because it's double or triple. We're going to get into that with our next unit when we talk about scaling things. So 135 is what percent of 45? Well, 45 is 1/3 of 135, or 135 is 3 times or 300% of 45. Some more percents. 3.5%, 3.5 is what percent of 14? Again, another part to whole, 3.5 of 14. So 3.5 of 14, you just divide it, it ends up being 1/4 or 25%. Here's a different wording. What is 60% of 115? And these are all the percents. This is no different than a sales tax or a discount or tips, any of that. So 60% of 115, you just take the 60%, turn it into a decimal, 0.60, and then do 60 hundredths or 6/10 times 115 gives you 69. Same with this one, 42.2 or 42 and 2/10% of 635 and 4/10. It's just a straight multiplication. We're just doing a percent of a number. 42.2% multiply by 100 because it means per 100. 1 by 1, 2. That gives us a decimal of 422 thousandths. So we multiply our 0.422 times our 635.4, and that gives us 268.1388. So what's 42% of 635? It's 268. And does that make sense? Yeah, 50% of 635 would be like 317-ish. So 40% of being 268. That makes sense. So that's a good check for our answer. The remaining question is all about baseball and softball. And I talked to Mr. Heffernan the other day, and he said you guys should be all over doing any kind of batting averages or any kind of baseball statistics. So Stacy's batting average is, she's batting .420. She has 47 hits and 119 at-bats. Stacy they tell us in the batting average, and Becky they tell us how many hits are at-bats. So Becky has 47 hits and 119 at-bats. So what percent of the time does Stacy get a hit? Stacy is 420. So you can translate that 420 or 420 thousandths into 4200s or 42%. So 42% of the time Stacy's at bat, she gets a hit. What percent of the time did Becky get a hit? Here we only have her hits and her at-bats. So 47 hits out of 119 at-bats ends up being 3,949 10,000ths, which if we were to round that up would be about 39.5% of the time. So Becky's batting a little bit lower than Stacy. During a doubleheader, Stacy and Becky each bat 18 times. How many hits would you expect Stacy to make? Well, Stacy, we just figured out her percentage is 42%, right? Because 420 out of 1,000 times, or 42 out of 100 times, she's going to get a hit. So we can take that 42% and say 42% is how much she usually gets a hit. Multiply that by the 18 at-bats. 42% of 18 is 0.42, 42 hundredths, times 18 equals 7 and 56 hundredths. So she can't get 7.5 hits. She's either going to get a hit or she's not going to get a hit. So we can just say this one's 7 or 8 hits. Now same with Becky. Becky's batting average, if we did it as a percent, was 39.5%. 18 at-bats, you take the 39.5% times the 18 gives you 7 and 11 hundredths. So same thing, it's either going to be 7 or 8. She's probably closer to 7, where Becky's slightly closer to 8, but either you can safely say 7 or 8 hits. Suppose Becky gets 11 hits during the doubleheader. Express Becky's new batting average as a decimal. So originally Becky had 47 hits. Now she has 11 hits. If we add those two together, she gets 58 hits. Originally she had 119 at-bats. Now she had 18 at-bats, and that's equal to 137 at-bats. So her new batting average is going to be her at-bats, which is 58 hits over her at-bats, which is 137. If you take the calculator, divide those out, you get 423. So she's going to be batting 423 thousandths. Remember the keyword had to do with the first problem. What was that keyword? Write it down on your paper. Thanks. Bye.